Now these match. Before they match, we have to state NPVs. So we have x can't equal, I don't know what's going on, 3. So these cancel, and we get 2x plus 3 over negative 3. Now if you had negative 2x plus 3 over positive 3, that's the same thing. Either the top has to be negative 2 or the bottom has to be negative 3. They both can't be negative, but one of them has to be, and it would cancel the other one off, right? And then we say behind it, x can't equal 3. And I don't know how to get it to stop showing the eraser after, but it is what it is. The second one is a subtraction. When we have a subtraction, our very first step is to see if we can do something to our denominator so that we can make them be the same. There's nothing I can do. One is an x plus 1 and one is an x. I gave you this one specifically because it's easy to do and it gets done wrong about half the time. So we have x plus 1 and x, okay? One is a binomial, one is a monomial. Can I make a binomial be a monomial and a monomial be a binomial? No. Some people say, well, I could just multiply that second one by plus 1. If I take x and I multiply it by plus 1, I have x. I'm no better off, okay? So when they're opposites like this, when one's a monomial and one's a binomial, you just have to multiply them by each other. There is no options. And this one by x plus 1. So we get an equal sign running down the left-hand side because there is no equal sign in this and we're just simplifying. So on the top we have 3x and we don't distribute our denominators over x plus 1. And then this one we get minus. Rewrite our denominator. Distribute our numerators. 2x times x is 2x squared. 2x times 1 is 2x. 1 times x is 1x. 1 times 1 is 1. We get one denominator, and we have to remember to subtract everything after it. So all of these are going to change. So we're going to get 3x minus 2x squared minus 2x minus 1x minus 1. Okay? And then we have to collect like terms. So on the top, we're going to get negative 2x squared by itself. What is it with this for? But we have 3x, so 3 xylophones minus 2 xylophones is 1 xylophone. Minus another xylophone is none. They cancel each other off, and I'm left with minus 1 over x plus 1. X can't equal 0 or negative 1. All right. The second one is a solving one, and I know it's solved without me writing solve. I used to have these above, but then I shrunk them off to see if you guys could do them without the words, because you should be able to spot the difference between 1, 2, and 3. 3 is a solve because it has an equal sign in it, right? When it has an equal sign in it, your goal is to get x equals something, some sort of answer. Now, what we can do is we can spot that there are similarities here. So this one is 3x, x minus 5. I can't do anything to it. And then this one is 10. And some people will say 5x minus 25 and x minus 5 have nothing in common. But what you can do is you can spot that. You can take a 5 out of the second denominator. And you're left with x minus 5. Now, what can I do? I can just multiply this one by 5. So I'm going to get 15x over 5, x minus 5, equals 10 over 5, x minus 5. Now, once they have the same denominators, we can set the numerators equal. That's the point of solving. So now we can go 15x equals 10. Divide by 15. X equals 2 over 3. And then I have to follow behind with x can't equal 5. Now, what if my answer was the NPV? What would I do? Yeah, you circle it, a line through it, and say extraneous, right? Every single time. It does it, so I'm good. I can box it. Now, we're going over linear and cubic, which is what we've done before. So, linear graphs are from grade 10. Linear graphs, they have a straight line and they just go, correct? What's the minimum number of x-intercepts a linear graph can have? 1. It has to cross through somewhere. And the maximum is always equal to the degree. Linears are degree what? They're degree 1 because the largest exponent is the degree. So it has a minimum 1x intercept and a maximum 1x intercept. So that's why linear graphs always have 1x intercept. Degree 3 is disco, and they either do, degree 3s either do this. Awesome, thanks board, I love you so much. Hope it knows I was being smart with it and not truthful. Degree 3s or cubics do that, which has a max and a min, so 2 turning points, or no turning points with a point of inflection. They can just do this where it's just a curve. So we talked about this. 2 turning points, no turning point. We agree? Now, degree 3 graphs can have at minimum how many x-intercepts if they're discoing? 1. It's going to have to cross through somewhere, right? It may do some curves in between, but no matter what, one arrow's up and one arrow's down, so it's going to have to cross through somewhere. Yes? What's the maximum number of x-intercepts that a cubic, a degree 3 can have? 3. It's equal to the degree. So if it's degree 3, it can have at maximum 3 x-intercepts. It can have at minimum 1 because it's discoing, and it can also have 2. And remember the leading coefficient. So this is positive 2. What does the leading coefficient tell me? How the graph ends on the what? On the right. How it ends on the right. The degree tells me how it ends on the left. If it's an odd degree, it discos. If it's an even degree, it's going to end in the same direction. Okay? So this one is a positive 2, so I know it ends up on the right. And I know it ends down on the left because it's degree 1. So it's a line. It's a straight line. What is the y-intercept of this equation? The -6. So your constant is your y-intercept if your equation doesn't have brackets. You see how this equation doesn't have brackets? If it had brackets, you would have to distribute the brackets first to collect like terms, then give me the constant. Okay? So this one here, it's a y-intercept at, and this should be a coordinate. If it isn't, you change it. 0 and -6. It needs to be a coordinate, not just -6. That is no y-intercept, that's just a number sitting on your page. 0 and -6 is a y-intercept. So it's not a coordinate, you need to write it as a coordinate. Now linear graphs disco. So they go out to the left and right forever, and they go up and down forever. We agree? So my domain, and if you're just like willy-nilly winging your domain and your range, and you're not writing it the same as me, you won't get full marks. If you're like, well, it's pretty much the same. Pretty much the same is not the same. You might as well write something totally wrong, because it's not the same. Okay? If you don't trust me, then when the test comes and you don't write it the same, you're going to, because your mark's going to not show a good mark. It's just not going to be. So when I say that every single thing matters, and you need all the squiggly brackets, and you need the line, and because it means something, trust me, because I'm walking around and people still are not writing their domain and range the way I am. So I feel like you're not trusting me. Trust me. I'm telling you how it's going to be marked. Okay? So my domain means the set of. That is what the squiggly bracket means, and that's why it needs to be squiggly. The set of x values. And why is it x values? Because my equation is y's and x's. If it was like y equals 2m minus 6, then I would say m for domain, because that would be the variable that they use. But they used x, so I can use x. X, straight up and down line, means such that x is an element of the real numbers. What happens if you forget the squigglies? It's not right. What happens if you forget the straight up and down line? It's not right. What happens if this E is something like this? Is that what I wrote? Can you just willy-nilly change your E to be whatever you feel like it should look like? No. It's literally like a C with a line down the middle. That means the element of it. It's a symbol. If you go in when we go to type up notes or tests in Word or in Google Docs, we have to go to the math equation editor and go take that E out because it means element of. Like I don't have a choice to just type an E if I want to. Okay? It means something. Range, same thing. The set of y values such that y is an element of the reals. And it would benefit you to say it correctly. To say what I'm saying as you go along, because then you won't forget things. The set of y values such that y is an element of the reals. If you keep saying it over and over and over, it starts getting locked in your head. There's like a proven thing that you have to see something 10 times before it even hits your long-term memory. So you saying it, you'd have to say it at least 10 times before it starts hitting your long-term memory, which is where you need it to go. Short term is a scary place. That means it can drop out like no problem. Like the weekend, she gone. Yeah? Okay. So we're going to go to our notes. We're going to go to the quadratics. So we have y equals negative 2x squared plus 3x minus 10. Everyone's typing it in. So everyone should have that sitting on their calculators. Zoom 6, it'll set you to that. That's what you should be seeing, this little teeny tiny parabola at the bottom. Now you know it's a degree too, and I really hope you know that that's a parabola. It's one of those upside down, like it's either a U or like an upside down U, right? It doesn't matter what class you came from, 20-2 or 20-1, you did quadratics in great detail. It doesn't matter what course you came from. This is like the fair game course, this unit, because you all came from the same grade 10s, 10Cs, and it doesn't matter if you came from 20-1 or 20-2, you are of no deficit to this unit. It's always the same. So I'm looking at this calculator though, and I'm saying, I need to see more here. Like, so what I need to get you guys to stop doing is changing every part of your window to just really large numbers so you can see stuff. Okay? How do I know you do it? I've watched it. It's a scary place to be. You cannot be those people. Don't just go willy-nilly going, I'm going to change them all to negative 100 and 100. And then I can see it. Not always better. Okay? So, when I was in high school, I totally did that. So I know it's not good. Because I didn't have a clue how to set a window. Now, I'm just like, okay, here is my window. It's this little window that's sitting in front of me, correct? And I can only see what displays on that window. But I know where the rest of it's located. Correct? Like if I look at this window, you guys have phones where you can zoom in and zoom out. You know where to zoom in order to see more of what you need to see on your phones. You all do. You're not going to go like this. Like that's what you do. When you guys change your window, you're literally just like, Pacha, Pacha. You wouldn't do that on your phone. You'd be like, hey, I need to see here. I'm going to widen this. Right? Would you not? I need to make this bigger because I need to see down here. We agree? What is that on your window? Is that your Y or your X? That's your Y. Is it your min or your max? Your min. I need to see down here. I need to spread this. I want to make this line longer. I want to see down here. That's where the graph is. So do I have to change my X min and my X max and my Y max? No, the only thing I need to change is my Y min. So I go to my window, and I go to my Y minimum, and I'm going to try negative 20 and see if I can see it. And I can see it. Did I have to change anything else? Would I go to my phone and just like slide everywhere and just zoom it out? No. You'd go to the bottom, you'd be like, and then you'd see it. It's the same thing with these. You just don't get to go through. Someday they'll let you do that. You're not at that day. These babies haven't changed since I was in high school, so I don't know when that day will ever. But we're here. And we can see it. We didn't have to move every window. We agree? Okay. Now what I want you to do is I want you to press second graph again. We're just reminding ourselves of where stuff is on our calculator. So if we go second graph, we can see tables, we can see values, correct? But what I can't see most often is my x-intercepts, because sometimes they're decimals, and I'll never see my max and my min, because most often they are decimals, okay? So go back to your graph, just press graph. The first thing before I go to draw a graph, I will always find my mins and my maxes and my x-intercepts. What's the great thing about this graph? There are no x-intercepts. So it's the only thing I'm going to look for. If you don't know if it's a maximum or minimum, visualize me as a Care Bear climbing that. And I'm on the max or the min of that hill. I'm on the maximum unless someone is going to get down on their feet and I can step on their back. I'm as high as I'm going. So I'm at the max, correct? Now what if it looks like this? I'm a Care Bear. Where am I now? I'm at the minimum. It should make sense. You'd be like, is it up or down? Is it minimum or max? Like, it should make sense to you. You climb to the top, you're at the max. You climb to the bottom, you're at the mid. Right? So this graph, I'm going to erase this because this is going to be confusing later. This graph has a maximum. We agree? And we want to calculate something. How do we calculate stuff? We go second, trace, because what's the word behind trace? Calc. We're calculating. When we're pressing second, we're no longer actually using the buttons. We're using the little words above the buttons. So second trace makes me calculate. And am I calculating a min or a max? A max. So I need number 4. Every single person should be doing this. Remember, I get scared because I like bringing the calculator up because you can see the steps. But the moment I bring the calculator up, you put your calculators down, which is completely unproductive. Okay? So now what does it say? It says left bound. It'll say left bound and right bound for a lot of different things we're trying to find. But all it means is I need to be left bound of what you're finding. And I'm trying to find the maximum. So I need to be on the left of it. Well, I already was, but I'm going to be super left. So I'm going to hit enter. Now it says right bound. Now I need to be on the right side of the maximum somewhere. And I can hit enter. And then when it says guess, I hit enter. So this one's at 0.75 and negative 8.875. Right, I'm still on eraser. Okay. Now, do I say stuff for a reason, or do I say stuff just to, like, say something and then you shouldn't follow it? No, not just to say something. I say stuff for a reason. So if I tell you to write something down, or I tell you this is important, I tell you you have to do this, it's because you have to. It's not because I'm just giving you extra stuff to write on a page. So when I go to graph this, I have to find my max or my min first, but also my window was changed to negative 20. Now, do I have to do 20 ticks? No. I'm going to show you how we can adapt and not have to write numbers on every single line. So we draw our lines. They should be straight. If this was a paper, I would be using a ruler. If I got any close to a ruler on here, it would be unhappy with me. But I can use these. Let's do this. Ooh, I let go of that the wrong time. There used to be a double-edged one. All right. Make sure you have arrows at the ends. Then I'm going to go 1, 2, 3, 4, 5, 6, 7. Now, some people think your scale needs to be the same. And I know when you're younger, you would actually go like 1, 2, 3, 4, 5. Like you write every single number. You don't have to do that. You just have to state the scale. So I'm going to make my Y scale be 2. So that means every single one of these ticks is 2. The catch when you change your Y scale to anything but 1 is that you have to remember that it is 2. So you'll write 2, and then you'll count down 8 ticks for 8. You have to watch yourself. You have to count down 4 ticks for 8, right? So my Y scale is 2, and then I'm going to make my X scale be 1 because it doesn't have to be 2. I didn't change anything there. So I'm going to make my X scale. That is X scale. Pretend there's a C in there. X scale is 1. Y scale is 2. And the first thing I'm going to do is plot my very first point, which I found, which was my minimum, or my maximum, sorry. It was at 0.75 and 8.875. So this is 2, 4, 6, 8. Well, negative 8.275. So it's about here. And I'm going to label it so that we know what it is. So it's 0.75, comma, negative 8.875. Okay. How do we get more points? Do we just wing it now and hope for the best? No. If you have points, you need at least like 5 to make a nice graph. I would try and do more. What do we have to press now? Second graph. So when I have this on here, I would have to go second graph, And now pick points on both sides of that. So like the 0, the 1, the 2, -1, -2. So that's what I'm going to do. Put it in here. So I have like -2 and 24. So that would be 12 down. 2, 4, 6, 8, 18, 20, 22, 24. So -2 and -24 is here. -1 and -15. 2, 4, 6, 8, 10, 12, 14, 15. 0 and -10. 1 and -9. 2 and -12. 3 and -19. So remember I told you the only graphs I can show you are degree 1, 2, and 3. Linear, quadratic, and cubic. So really the only one you have not seen before is cubic. That's the only one I can give you. What's the only graph of the 3 that can have no x-intercepts? Degree 1, 2, or 3? Degree 2, because it has arms in the same direction. So this is a degree 2 graph. If the arms are in the same direction, the whole graph could be below the x-axis, or the whole graph could be above. What we've talked about already is linear and cubic, and they disco, so they have to cross through at some point, right? But degree 2s never have to. So degree 1 and 3 have at minimum 1 x-intercept and at maximum the degree. Degree 2 has at minimum 0 x-intercepts and at maximum 2. So it could have 0, 1, or 2. We're going to see where it has 1 after this. So what's the leading coefficient on this equation? -2. So that tells me how it ends on the right. That doesn't change whether it's degree 1, 2, or 3. That leading coefficient tells you how it ends on the right. So this ends down on right. And because it's degree 2, it's an even degree, it also ends down on left. Odd degrees, degree 1 and 3, end in opposite directions. Even degree ends in the same direction. What's the y-intercept of this function? Yeah. It's what, Bree? 0 and -10. It's based off of our constant, right? And you said it exactly correct because you made a coordinate and you didn't just tell me -10. So it's going to be 0 and -10 in a coordinate, not just -10. If you wrote -10 again and didn't put in a coordinate, put in a coordinate and remind yourself it has to be in a coordinate, it has to be in a coordinate, it has to be in a coordinate. How many x-intercepts does this one have? 0. What's the domain? X, such that X is an element of the reals. And the reason why is because my arrows are going out in opposite directions forever, right? So all the X is negative and all the X is positive count. So actually degree 1, 2, and 3 all have X such that X is an element of the reals. So the only time you're not going to get a domain of that is if it's a word problem. Is my range YER? No, it's not discoing anymore, is it? So I have to look and say, okay, what is my highest Y? Because this is the maximum. What is my highest Y? What is this? It's not the 0.75, it's -8.875, right? So that's the absolute highest my graph can go. And then I have graph below it, correct? So how would I write that in range? I would go Y such that Y is less than or equal to, and what's my highest Y? -8.875 YER. So remember, if you have a maximum, you have a less than or equal to range. If you have a minimum, you have a greater than or equal to range, right? Because the minimum means you're at the lowest you can go, and you have to only go higher. Maximum means you're at the highest you can go, and all you can do is go lower. So I'm going to give you another equation in the second one, and you're going to graph it properly and try and answer all the questions. So this is the next one I'm going to give you. Y equals x squared minus 6x. Or sorry, we'll go plus 6x plus 9. I want you to graph it properly and then answer the questions. I gave you this one specifically because people get tripped up when your x-intercept is your vertex. So when we type this one in, when you guys type this in, you get -3 and then you get like 1.2 e to the -12. Everyone's looking here. Look at my face. Look at my face. Look at my face. Do not call me over at the test and be like, this doesn't look like 8.7 when it's 8.7 e to the -12. And I'm going to be like, yeah, you're right. It's not 8.7. And you're going to like want to draw 8.7 and you're going to call me over. Do not call me over. Look, if it has an E, a capital E in the X or the Y, what is it telling you? 0, right? 0, 0. Do not call me over and be like, Mrs. Lepp, this doesn't look like 8.7. You're right, it doesn't, because it's e to the -12, which is 0, because that's just 0.11 zeros and then some numbers, right? So 0. We agree? All listening? Taking that in? In 2 minutes, when someone asks me about e to the -12, I'm going to be like, okay. Now you can't take me down for this day, though, so I'll stop you. -30. This is great. All right. And then we have some more coordinates. Or do we just wing it from here? We have one accurate point, so I'm just going to wing it. Shunk, shunk. Is that what we do? No. Also, I should say y scale of 1 and x scale of 1. And then I know I have a y-intercept at 9. So now I have enough accurate points, right? I can just wing it. No, I don't. But you know how many of you do that on the test? Saddest day ever. It's so sad. So please don't. You need at least 5 points. That's what I'm going to say now. 5 points. I want more than that, but I will accept at minimum 5 points. So I go to my graph, and it tells me negative... Did I type this in right? X squared plus 6x plus 9. Oh wait, it tells me -3, there we go. Then it tells me -4, 1. And then it tells me -5 and 4. And then -6 and 9. Ooh. And then we have -2 and 1. And -1 and 4. And then it's kind of rounded at the bottom. It is not like a V. Please don't draw a V. It's slightly rounded. Like if you look at yours, it's rounded, correct? On here. And then you guys just don't V it. That is not. Absolute values are V's. I really wish I wasn't wearing this costume right now. I am boiling. Leading coefficient is what? It's the head of this that's really hot. Getting air flow. Okay. What is the leading coefficient? 1. Good answer. Thanks, guys. It's a +1. And what does that tell us? Ends up on what? On right. And because it's degree 2, it actually ends up on right and left. What's my y-intercept at? 0 and 9. How many x-intercepts? 1. It was tangent on the x-axis. My domain is XER. It's the set of values x such that x is none of the reals. My range is done terribly if I give you the x-axis as your vertex. Because a lot of you will pick -3 as the y value, and -3 is not the y value. -3 is the X value. What's my lowest y on this graph? 0. 0. If you're someone who picked -3, you fell to the error. That will be a multiple choice answer choice because you just picked the wrong one because you don't want to put 0. The lowest that this graph goes to is 0 or higher. So we're going to go y such that y is greater than or equal to 0. Y is an element of the reals. And this is a minimum at -3, 0. All right. We're using some thinking caps. I'm going to lose you. Everyone, grab your thinking cap. Throw it on. All right. I'm going to lose you. Just wait. Okay. We're doing linear graphs. Everyone's paying attention. I lose everyone at this part of the lesson. I don't want to lose you. We're going to draw a graph. This one is y equals ax plus b. It is a linear graph. So somehow on this paper, I'm going to have a this or a this. We agree? I get people linears and I get some curving things going on. I don't know. It's a linear. So you have only two options. This or this. Those are your two options. If you give me anything else, we got problems. Right? Okay. So we're going to draw ourselves a Cartesian plane. And we have to go based off of what I give you. And none of these have numbers. So that's where I lose you. So paying attention. I don't want to lose you. Okay? So I know b is this back number, which is the constant. And the constant is always what? The y-intercept. We agree? So I'm saying that b is greater than 0 in this example. So I'm saying the y-intercept is greater than 0. So I'm saying the y-intercept is positive. We agree? So I need to draw a positive y-intercept along here. So I have any option along this line above the x-axis. So I'm going to put it here. Why? Because I felt like it. You can pick any other spot. It just needs to be greater than 0. We agree? Right, Colton? With a dot. Huh? Yeah. Okay. And then we have an a in front. A is our what? Leading coefficient. Thanks for all the answers. And our leading coefficient tells us how the graph ends on the right. So this one here says a is greater than 0. So a is positive. So does it end up or down on the right? Up. I made it end up. How does it have to end on the left? Down. How could I draw the rest of this graph? Well, it has to be a straight line. So extend it. Right? It's a linear graph. We have no other choices. It has to go like this. I can't do anything else. I can't change the slope. But could I have drawn one that's steeper? Sure. Less steep? Yeah. But it has to be a positive y-intercept and it has to be a straight line. And it has to end up on the right from the restrictions I gave you. So let's look at this one. How is this one different? Well, this one has b is greater than 0. So my y-intercept has to be what? Positive, right? It has to be above the x-axis somewhere. So I'm going to make it here because I'm going to make it more extreme than the other one. But it doesn't matter. I could have drawn it there, correct? Now I say a is less than 0. A is my leading coefficient. So if a is less than 0, it means a is negative. And if a is negative, what does that mean? I end right in the negative. So I'm going to end negative. So I'm going to end down. It's a line. So how do I end up? On the left? With it. I just extend it. Right? Could I have made it steeper? Absolutely. I just need to end down on the right. Okay, you guys are trying C and D quickly, and then we're moving on. So, this one, we go to our y-intercept. Our y-intercept is negative. So down here somewhere. A is greater than 0. So my leading coefficient is positive. So I end up on the right, which means I extend that line. It's down on the left. We agree? Could it be steeper? Sure. Could the y-intercept be anywhere between this and that? Yep. Okay. This one, I have a negative y-intercept, and I end down on the right, because it's a negative leading coefficient that is negative. Pretend that's a straight line. Then we're going to flip over. We have quadratics. So now we have parabolas, correct? So still following the same thing. I have a c at the back as my constant. My constant is greater than 0. So I know I have a positive y-intercept. So up here somewhere. And my a is greater than 0, so I know on the right it is up. But what do I also know about the left when it's a degree 2? When it's a quadratic? It's also up, right? So if it's up on the right because of this, it's also up on the left, and it has to be somewhat symmetrical. So it can look like this. I could have drawn something like this. You know what I mean? I could draw something like this. I could have drawn it like this. As long as this is positive and these are both up. I could have drawn it this way, right? I could have went this way. Still both would work, right? It needs to be up on both arms, positive y-intercept. This one needs a negative y-intercept and up on both arms. Negative y-intercept up on both arms. This one, negative y-intercept down on both arms. Ooh, that is not a negative y-intercept. Check that. And this one needs a positive y-intercept down on both arms. Then I want you to flip ahead a page because I have a little bit of questions for you to work on. I have to flip ahead 2 pages, sorry. So we're on this page. For homework, and I'm checking it tomorrow, number 1, 2, and 4. This one will be checked. If you're not done it, I'm keeping you for scheduled help to work on it. So we have 1, which you're allowed to use technology for and answer all these questions. Remember, number of x-intercepts is not what the x-intercept is, it's how many there are. When you put in your calculator, you can tell, right? Y-intercept, you can pull off the constant at the back. End behavior tells you how it ends on the right and the left. Domain is domain, range is range. Number of turning points, if you have a max or a min, you have a turning point. So remember, if it's like this, how many turning points do I have? This would be 2 turning points. If it's like this, how many turning points do I have? 0. So you're doing 1, 2, and 4. And they are not long questions. They're very short. Oops.